Okay, so we just had an explanation and overview of the user-defined type based on a enum. And now we're going to see actual code, see if it runs, and get a little bit more of a feeling for it. So here's where I'm declaring the type, a enum. We need that as a keyword. Day, that's the tag name for that particular type, and then the enumerators: Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and this declares this as a type. It's actually a restricted form of integer type, with Sun, Mon, Tu, When, Thursday are secretly integer constants, can't be modified. Their value is given as 0, first in the list, 1, 2, 3, 4, 5, 6. And as I said in the last lecture, if you wanted, you could change those values by doing a initialization inside with an integer value. But in most instances, we're okay with the default initialization. And here's a function that is going to act on that type. So when you declare a type, the type has a set of values, but also a type combines operations on it. And so you have to think, when you are doing a user-defined type, just like with a native type, what's an operation on floating point number? Well, divide's an operation. So you have to present natural operations so that the type is useful. So one thing we want to do is we want to be able to print them, and there is no way to extend in printf with new formats a day type. So instead, if you tried to use the standard formats like %d, all you would see would be an integer, and we'll show that in a second. So here we're going to use the day as a switch label, and we'll have a case: Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. And this is an idiom for doing a lot of work with enumerated types. Namely, each enumeration can be used inside a switch statement, and your behavior is determined by what enumerator that function is going to see. So if it sees Sun, it's going to print Sunday. If it sees Mon, it's going to print Monday, and so on. What if it sees a value outside one of those cases? Then will be a default. We'll assume that value is typically a integer value. We'll print it as an integer. It must be different than one of these integers. So somehow we printed something that's an error, and we'll let the person know that they attempted to print something that did not turn into a day of the week. And notice again, because we didn't emphasize switch, you should have come in just as knowing if and else, switch, and this is canonical for switch. You typically have an action with a break, an action with a break. You want to avoid a fall-through semantic where you would, without the break, get all these actions. You don't want a Sunday value to end up printing you all days of the week. So the breaks are, again, typical idiomatic for this kind of action. What if you want, if I tell you what's the next day and I say, oh, what's the next day after Friday? It's Saturday. So that's a common operation when you think about this as a data type. So here we're getting you next day. So we're passing an enumerated value, and we're going to return the next day. And what's the next day? Well, 0. The next day is Monday, which is a 1. We have a special case. When it's Saturday, it's 6. When we add 1, we get to 7. but there is no 7. That would be outside the range of these enumerator types, so we have to map it back into the next day, which is Sunday, and we have a simple operator, a nice use of the modulo operator. Okay, and we're just going to use this in a very simple way. Let's look at main. Main is going to start by declaring a variable. Today is Friday. Okay, let's make sure it prints right. And then we're going to show you some of the problem. Remember in that first lecture I said C is a weakly typed language because it allows a lot of implicit conversions. And that's true for enum, which is really a form of int type. And so today is allowed to get other values than those strict enumerator types. Other languages which implement it as a concrete type avoid this by doing heavy type checking, and this would be causing an error. Unfortunately, we're living in the C world, so we do the best we can. This will, if we've got our logic right, this should print out as an error. We're going to jump to a new line. We're going to get a next day and see what the next day prints. So let's try and run that program. I already compiled it. And sure enough, we had assigned to the day Friday, and we get the print Friday, even though it's secretly 6. If we try to use an integer outside that range, we get the default value, the default case, and that's 7, and it shows that it's an error. And then when we do next day, we get Saturday. Okay, so we saw how to make use of the enum type, and you can try to add to this type by creating some routine you might think of, like why not create, instead of a next day routine, a yesterday routine. So you could have a tomorrow routine and a yesterday routine, and try and write that piece of code. I'm going to leave you with one further little idea. I'm going to look at very similar code to what we just looked at, but there's going to be one change. And in that one change, we're going to add what's called a type-def declaration. So when we go over to user-defined types, this is very useful. Type-def is another keyword, and it says associate the type enum day with the term purely day. So this now, instead of enum day, lets us everywhere else use day. So day can be used there, day can be used here, day can be used as a return type. In other words, it works exactly the same, but it takes something that's somewhat complex, and we'll see that routinely in more advanced typing, that type-def is useful to improve the clarity of your program. Okay, that's it for this topic.